Let's take a look at how unit testing works. So I'm going to go ahead and open up the source file named copy.c. And what you're going to see here is a function implementation for the copy function. And notice it's got a destination pointer and a source pointer and some number of bytes that we're attempting to copy. And if we were to look in the header file for this, so if I were to actually instead open up include copy.h, this is where the header file is. This is where our documentation for this function would be, because the header files serve as documentation. And if we read this, we see that we're copying a block of memory, and the return value of this function is going to be the destination. So this is an ergonomic decision. The copy function, when it's done copying some number of bytes from some source location in memory to some destination location, it's going to return that destination, and then we could use this as part of an expression in our code somewhere else if we wanted to. Okay, so I'm going to go back to, and actually, why don't I try using the file open here, and I'm going to open up copy.c. Remember, it was Control O to open up that sidebar, and Control O to toggle it down. And now I want to take a look at some unit tests on this. And when you're writing some code and looking at unit tests, you often want to split your window. So I'm going to use the Control W, and I'm going to split horizontally because my font size is so big, but you might want to split vertically. And that tends to be what I would normally do if I weren't recording in this giant font size. And so here I'm going to open up using Control O again, the test in my unit test for copy, right? And close this back down. So what we're going to see here is some structure for a Google test. And Google test, as I mentioned in the previous video, is a C++ testing framework, but you can test C projects in it as well. And it's one of the most commonly used C unit test frameworks that there is today. And this is what Google uses internally on their projects as well. So this is the real deal. And we have to do one funky thing when we are working with this, when you're working with C projects in Google Test. We have to say that there's a special distinction that we are using the C programming language, and we are pulling in the file that we're going to be testing our functionality from is pulled from copy.h. Right? And so Google Test has some macros defined in it, just like we've seen macros in C before. And these are different from Vim macros, which I know we talked about just earlier. But test here is a macro. And what it's actually doing is specifying a function and setting that function up in such a way that when the Google Test framework wants to go run this function, it knows that it can run it, and that this is actually a function that's testing. This should be designated as a unit test. And we'll talk more about unit testing and some strategies for unit testing in the next lecture. The first parameter we're seeing here is really the name of this test module. So this will be the same. We're testing the copy function. So this is the name of the module, and we see there's another test below it. This is the name of that module that we're testing, or the name of the function. And then we're trying to describe that test here with another identifier. So part of this function says that copy should return the destination pointer address. And so here's a simple test to try and test that. Within the test body, it's as if we're writing a function, right? And so these first few lines are setting up the parameters of the test, right? So we're saying, okay, let's have this char array. It's the string hello. We're going to set up a destination array that's going to have space for the same size as the number of characters as there are in this source array. And our goal here in this call to copy is the function should be copying this many number of bytes, so the size of source, from our source pointer to our destination pointer. So we're effectively trying to copy over all the characters from source to destination. But what this test is really about is not that functionality. It's whether or not we're returning the destination pointer. So we should expect that this destination pointer that we pass in is going to be have the same value as what this function returns. So we've set up a variable RV for return value to hold that. And then we're actually asserting part of our test. Whether or not this test passes or fails is based on this assertion. And we're trying to assert equality. And we're saying we expect the return value of this copy function call to be equal to, and this is what the name of this assertion is telling us, we expect this return value to be equal to this destination, right? And so currently this test fails, right? So if I run my test, and this is actually another part of Vim that we need to slow down and mention really quickly. If you're not comfortable with tmux and having a separate pane open for that as well, one of the ways that you can run commands from within Vim without leaving it is you press colon and then the exclamation key. So the exclamation key says, hey, let me run a shell command right here. And so if I run make run here, we see that the program ran. But what I really wanted to run here was make test, right? And so I had run clean before. So the first time you run make test, there are a number of steps that set up the Google test framework in our project. And I'm going to fast forward to these steps being completed and the tests being run. Okay, and so we see that we have 2 failed tests. There are 2 tests in that file. And let's go see if we can find the copy return destination test that we were just looking at. So sure enough, here it is. We're running the copy return destination test. And what we see is the return value was null, but we expected it to be equal to the destination, and that had a separate address, right? So this test failed because our assertion failed. These 2 values were not equal, right? So after you run a command in Vim, if you press enter, it brings you right back to where you were left off. So let's see if we can get this test to pass, and then I'm going to leave it to you all to try and get the other test to pass. So the second test was this one, right? But we'll take a look at that in a second. So let's see if we can get this test to pass. So I'm going to press Control W to move my window and K to move up and switch windows. And this is a simple test to get passing, right? What we need to change here is that we return the destination pointer, right? That's all that test is about. This function's documentation says you can expect the return value of calling this function to be the exact same as the destination you gave it, right? So I go ahead, I make that change. As a reminder, you can save changes in Vim without exiting Vim by :W. This writes your changes out, right? So :W saved that. And now if I do : exclamation point in here, I can press the up key to just run this make test again. Let's see if this passes. So we have to rebuild a few things, but notice it's much shorter the second time around. And notice that we 2 tests ran, we passed 1 test and we failed the other. And so if we look up, we see that sure enough, the copy return test passed just fine. It was okay. We satisfied that test, but we did not satisfy the copying of a string, because what that test is looking at is a little bit different. So now that we've passed this test, we can turn our focus to one that actually looks at, well, did we actually copy the contents from source to destination? So again, your goal here in this copy function is to copy all of the bytes from source to destination based on this call of copy, right? And so notice there are 3 parameters we're passing here. Destination corresponds to this void pointer, destination, and source is constant. So that means we're not changing anything about source. We're using source as the input, and we're trying to copy its bytes to destination. And then lastly, we've got the number of bytes that we're trying to copy, okay? So one of the things that I will give to you as a matter of helping you out and getting you started on correctly implementing this is you can't assign the contents of a void pointer to another void pointer. In other words, we can't say something like this, destination is assigned source, right? Because the compiler doesn't know how big does what we're pointing to, how many bytes in memory does what we're pointing to, what unit are we actually referring to? Does this mean copy 1 byte from source to destination, or 2 bytes or 3 bytes? If these were pointers to doubles, right? So double floating point values, we would copy 8 bytes. And so the trick here is kind of a hack. And the trick here is we're going to set up a char pointer. And remember, a char is a single byte. and I might shorthand this to be D. That will be assigned our destination, right? And then const pointer to a char for our source is going to be assigned source, right? And now if we were to try and say copy D is assigned S, notice that this works, right? And so now, because we are claiming that what this D pointer refers to is a single character or a single byte, we can copy a single byte from the address of S to the address of D, right? So your goal in this next project is just to, now that we've copied a single byte from the source to destination, your goal is to copy some number of bytes, right? So you want to repeat this process some number of times and be sure that you're moving your pointers forward such that you're copying over subsequent values, right? So when we run make test again, your goal ultimately, oops, I needed to save my changes, so don't forget to save :W. And when I run make test again, we're going to see that we have a partially successful copy here. So notice that in the output of this, we copied H over successfully, but the rest of this value was garbage, right? So your goal is to try and complete this function, copy, that will loop through some number of bytes and copy them from a source to a destination.